Hello everyone, my name is Paul Kinlan. This is me. I'm a Chrome developer advocate on the mobile web team here at Google. And you can find me in all the normal places on Twitter, Google+, and GitHub, and a couple of other places. I'm actually really excited to be in Korea. This is like the furthest east I've ever been in the world, which is it's pretty cool. And we've only been here for 2-3 days, and we hope to go and explore a little bit more over the weekend before we move on to Tokyo. And before I kind of get into the talk itself, a lot of the reason why we're here is to understand more about the Korean market, what it means to be kind of leading the way in the mobile space. You know, what happens here is going to happen elsewhere in the rest of the world in maybe 2 or 3 years' time, especially with regards to 4G rollout for networks. So what we learn here, we can hopefully apply to the rest of our outreach work inside Chrome Developer Relations. So that's why we're here, and I'll get started. So the talk today is called Building Fast Mobile Sites with PageSpeed, Mobile Insights Tool. I need to work out how to start this one properly, but the interesting thing is that we're running this kind of project called Perf Matters. We think performance is a feature and should be planned in from the start of your kind of development cycle and not thought of as a kind of an addition, a thing that you do when you're testing your application or your website at the end of your project. And the reason why we think this is because the web isn't getting that much faster. Okay, the network connection speed is getting a lot quicker, but the actual size of pages, the page load time is actually only slowing down. And you look at these stats from 2012, this was from Google Analytics. The average page load time for mobile was over 10 seconds. And then we jump forward to 2013, and we see that, okay, maybe after 3 seconds, 57% of consumers say they're going to move on to a different page. But the important stat here is that pages are 8% slower now than they were in the summer of 2013. So in the space of, say, 3 or 4 months, pages have got nearly 10% slower. And this is for a variety of reasons. Pages are bigger, there's a lot more things on them, and developers probably don't particularly care about performance. But it turns out users really do care about performance. They just don't really tell anyone. So the question I have to ask, and why I have to kind of think whether this talk is important for you guys, is that I was looking at the stats that, you know, Korea has got a hugely rolled out, massive 4G network, more than, like, a percentage for the population, more than any other country in the world. And I need to work out whether we can get developers in Korea actually caring about performance and not just leaving it to the network operators and the phones to actually get faster. Because if we can't kind of get you guys excited about performance, then how do we get the rest of the world kind of excited about performance as well? Especially when it comes to kind of getting data down the wire or down the phone as quick as possible. So I want to look at this idea of the life of a request, and I've got two columns, a 3G column and a 4G column. And I know, looking at this now, you probably can't see the actual numbers, but we see that, you know, on average, the round trip time for a DNS lookup on a 3G phone is 200 milliseconds, so a fifth of a second. The actual connection to the actual host, once you've actually resolved the domain name, takes another 200 milliseconds. And the HTTP request itself probably takes 200 milliseconds. And that's not including the time it might take to boot up the radio on the phone, which for 3G, it can be anywhere between 200 milliseconds and 2.5 seconds. So when we're trying to get data and pages down to the user as quickly as possible, you know, on 3G, we've got a real problem. And then on 4G, it's actually way better. You know, it's 80 milliseconds normally round trip time for most operations. So you have a lot more kind of budget to play with. But that number is a little bit of a lie, because if we think about the slide before, it said it takes about 10 seconds to load pages, even on mobile. They were obviously taken in the idea of a 3G network. They weren't, like, there was no 4G networks when these stats are out. But the actual difference is maybe 4G is 3 times faster, so you might get to about 6 or 7 seconds. This 240 milliseconds is just one HTTP request. And I'm going to talk a little bit later about the size of pages. But the reason why pages are going slower is because there's more content on those pages, more requests coming out from them. So this 240 milliseconds is the best case time that you would probably get for every single request that comes out of your page. And we're going to talk about what requests mean, web requests on your page mean to the actual page lifecycle in a minute as well, and why we think you should prioritize certain types of content over others and certain types of requests over others. Because at Google, we actually believe you can get a page to a user in about a second, even on mobile. And I know Paul Irish alluded to it earlier on in the DevTools talk, is we think it is possible for you to build experiences on the web which are 10 times faster than they are today on mobile. So getting content out within 1 second. And hopefully with this talk, we will show you how you can start to do that, or how you can think about planning to do that. So how can we make fast mobile sites? That works. I had a big spelling mistake in this about 5 minutes ago, so I'm just trying to make sure this is correct. But we want to show you today how you can make fast sites. We've developed a tool called Mobile Page Insights. Now, I don't know whether, PageSpeed Mobile Insights, sorry. I don't know whether any of you know about PageSpeed. Does anyone know about PageSpeed? And one or two people, a few people. So the PageSpeed team is part of the Make the Web Fast team. They want to make the web as fast as possible, make it easy for developers to build quick sites, so you don't have to worry about how to optimize your site. But one of the things that we find is that developers don't, like we said before, don't really care about performance because they don't really know they've always got a problem. And the PageSpeed Mobile Insights tool is designed to show you that you potentially have problems on your site with regards to a mobile device, and then also how to go and fix them. So it doesn't tell you you've got problems and you need to go and work out what to do. It tries to tell you exactly what you should do to make your page fast. So a couple of the checks, and we're only going to cover 3 or 4 of them in this talk today, but they're the highest priority, most critical features or kind of problems that you can find on a web page which directly affect the performance for the end user. And they're ordered kind of in priority, number of redirects. We'll talk about what that means in a minute, but basically any redirect slows your site down significantly. Poor compression and minification. You'll be really surprised about the number of sites that don't turn on compression on their servers. Scripts, CSS blocking, and critical rendering path. This is relatively complex, and we're going to talk about it later, and I know some of you will be quite familiar with this. But we're going to talk about what it means to basically get content visible on the screen within a second. It might not be the entire page that is loaded within a second, but the user has this perception of performance because they see something on the screen within a second. And then there's obviously usage of caching. Caching is important, but we're not going to go into it today because we don't have a huge amount of time. So if you want to have a play with PageSpeed Insights, it's at the link, and I will share this out in a little bit later, but I'm going to try and give you a little demo. I have prepared this page just in case the demo doesn't work, so I can kind of run through it, but essentially it's a tool where you put your URL in, and it will go off and analyze the site. If you just give me 2 seconds while I don't do that. I'll break out, jump in. And this is basically the summary of results. So HTML5 Rocks is a developer resource that we own and run. And we are basically trying to tell people how to build great mobile sites. And one of the things that you find is that we need to be a great mobile site ourselves. So we regularly analyze our site to make sure that we're kind of meeting all the criteria that we say developers should follow. And as you can see, we've got a kind of a score here, 73 out of 100 for mobile, 89 out of 100. Let me just zoom in. 89 out of 100 for desktop. It's the mobile one that we're interested in the moment, and you can basically see a whole series of kind of suggestions about things that the PageSpeed service has done and detected problems with our site and how we should go about resolving them. So the first one is eliminate render blocking JavaScript and CSS, and I'm going to dive into that a little bit later about what that means. But it's one of the most critical things that you can do to improve the performance of your site. Avoid landing page redirects. As a big one, HTML5 Rocks has got a bit of an issue. We do 2 redirects to get the user to the correct content, which is a problem and we need to fix. And the server response time. If you want to get your site out to the user within a second, you have to deal with the fact that even on 4G, you've probably got 1,000 milliseconds minus the 240 milliseconds available to kind of go and build your site. So maybe 3/4 of a second to actually build your site. So we're probably okay on 4G at the moment, but on a 3G network, we only really have 200 milliseconds to actually be able to respond with the HTML from our server to the client. And there's a whole set of other criteria about enabling compression, which we're passing and we're doing fine. So if I was a developer, I'd go and look at those 3 or 4 different criteria to actually go and check our screen shrunk. There we are. And obviously this is the Korean translation. I'm presuming it means exactly the same thing as, as what I've just shown you before. But it basically prioritizes the things that we think you should fix. And I believe I got this right. I was looking for Korean phrases the other day, and I found this one, well begun is half done. Is that correct? Yes. Okay, good. It's not lying. So I think this is actually, the Korean phrase is, the way I understand it, is quite optimistic, right? You know, you do things well at the start, the rest of the project is a lot easier to complete, basically. And in the UK, we have this thing that says proper planning prevents poor performance. Actually, it's got a swear word in between, which I've deleted. So it's 6 Ps. But we are, as a country, are pretty negative. So we basically tell you you're doing things wrong, not you want to do things right. I want to say the reason why I've got this is because the PageSpeed Insights tool is very retrospective. The site is live on the internet and telling you problems that you've got. And what we really want you to do is take the advice that we're going to tell you today and use it at the start of your project, so you don't have to worry about the performance of your site so much as the project progresses and as you go to completion. And I think that's how I'm kind of interpreting this phrase, at least. So redirects. We think these are one of the most important kind of issues, and I'll tell you why in a second. Obviously, we saw the result before. HTML5 Rocks has got 2 different redirects. We go from html5rocks.com to www.html5rocks, and then we forward you on to the language translation site. So it's got 2 different types of redirects, a domain redirect and then a directory redirect. And both are not good, and if we get rid of them, we'll actually improve the performance of our site quite significantly. The reason why redirects are bad is because they can double latency, because especially with a DNS redirect, which is this, you basically go from one domain and forward them to another. So you go from, say, html5rocks.com to www.html5rocks.com. Now, where this is most prevalent on the web is when a user comes in on a mobile phone to a desktop-based site, and the server goes, we know you're on a mobile, we'll redirect you to the m.dot site, the mobile version of the site. Now, this is actually bad because you have to do a DNS lookup at the start, which is probably maybe about on 3G at least, is probably 200 milliseconds. Make the TCP connection, which is another 200 milliseconds. You probably won't get some content, but you'll get the redirect. And because it's a different domain that you're redirecting to, you have to do another DNS lookup, which is the same process again. It's another 200 milliseconds for DNS lookup, and then another 200 milliseconds to actually make the connection to the server, and then you probably go and get the content. Now, we actually have 3 different types, or 2 different types of redirects on HTML5 Rocks. The third one is the directory lookup. It's not as slow. It's kind of a little bit better, because you get to take advantage of the fact that you don't have to do another set of DNS resolution, and you don't have to necessarily always have to make a new TCP connection. You can just pretty much use the same connection that you're on, but you have to have the server enabled for HTTP pipelining. But in our case, we actually found this here. This green line here is actually a bug in HTML5 Rocks. And I think Paul Irish showed you web page test a little earlier on today. This is the same tool. We put web page test in, and it tests it from all around the world and shows you the latency and the request time for a number of things. And we've actually found a bug with HTML5 Rocks on this, because we send you the content and then redirect. Well, we don't send you the content. We generate all the content and then redirect you to something which is different again. So we've got a bug, and we found that actually with this tool. But redirects are pretty bad, and you should try to ignore them or try and kind of move away from them. Now, I understand that if you're developing an application or a site, and you've already got it live, then you're not going to be able to really change the infrastructure of your site. It's a big job to go to a fully responsive design site. But if you're starting a brand new project, like, really do consider a responsive-based solution, even if it's a server-responsive solution. And I know there was a question earlier on today about whether you should do user agent detection. Sometimes it's the best. It might be the best of a bad solution, the best option in a bad solution, essentially, because even if you do a server detection, don't do the redirect, send the different content out. And as long as you kind of have got the correct kind of search engine headers, then you're not going to suffer from SEO too much, or SEO issues or search engine optimization issues. But the preference from Google, and you'll see this all across Google, is to go to a fully responsive design site. But we understand that's not always practical, and sometimes you have to do things on the server. The best thing to do is just not redirect. Have the logic which separates out the two sites behind the scenes, and then serves the correct content to the user that way. It's not great, but it's a better solution than the redirect. So, yeah, save the user's time, no redirects. If we did this on HTML5 rocks, we'd probably save 300-400 milliseconds in the standard request lifecycle just by making sure that we do manage the redirects correctly. So compression is the next subject. It's never like a really interesting topic, compression, but it's one of those ones where developers never do it, it seems. We never seem to care about it, and I think you should. This is a site, this is actually a UK government site, so the NHS, for the National Health Service, has got a site. It's not mobile optimized, and it wouldn't actually matter if it was mobile optimized because they don't follow any of the basic practices at all. So they've got a whole load of issues. The one that we're going to talk about right now is the compression. You probably can't see it, but there's 673 kilobytes of extra content that don't need to be downloaded, that doesn't need to be downloaded on this site. It's content that does need to, I'll rephrase it, it's content that does need to be downloaded, but could be compressed and kind of, you wouldn't actually ever download that again. Essentially, that's 670 kilobytes. That's like nearly, it's not far off from a megabyte's worth of extra content, which was needlessly piped down the site. Now, the interesting thing is that they also have a problem with minification. They don't actually strip out extraneous content from their page. So these are like CSS files with extra spaces which aren't needed, tabs, JavaScript with longer variable names than need to be. PageSpeed Service or PageSpeed Insights will go through and work out potentially how much data you could save by following proper minification rules. And in this case, for the National Health Service, you know, if they had minification and ignored the compression, they could save 150 kilobytes quite quickly, which on a 3G network is actually quite significant. If we go back and we look at the compression, if they turn compression on as well, that's another, that's 600 kilobytes extra that they save, which, especially on 3G, it's probably not so bad on 4G, is actually a pretty good thing. The interesting thing as well, and we'll talk about this later, is that they make about 30 requests per page. So there's 30 extra requests, HTTP requests, that have to go out to the server to be processed for every request, and that's not a good thing. So our guidance is minify all CSS, JavaScript, and HTML. The minification is great because you don't lose any of the semantic meaning of the content. So the CSS will be the same CSS, mean the same thing. The JavaScript will mean the same thing and execute in the same way. And likewise with the HTML, you're just removing content that doesn't need to be sent to the user. And our other piece of advice is turn on gzip for all text-based content. You can turn it on for images, but you won't save that much space. Normally with text content, you can save in the region of about 50% of the bandwidth that you would send out. And just as I suppose as a side note to say that a lot of people don't actually turn on compression, httparchive.org, let me just load it up. If you've never seen HTTP Archive, it's a really, well, let me just, there we are. I'll fix that link. But HTTP Archive basically goes out and scans probably about 1 million URLs once a week, and indexes and aggregates every single request that is sent by the browsers that they automate, and then they produce some interesting statistics off the back of this. So they can tell you that, like, you know, most of the content, you can't see that at the back, but most of the content on the web is images. By far and away, the larger proportion of content is images. They've got other kind of really interesting stats as well, like the average individual response size being around 95 kilobytes. Now, there we are. Yep. Oh, cool. That by itself is not that interesting, right? You know, it's kind of cool that you can see the average response size. But what they also do is they dump all the data into a service that we run called, I think it's, well, what's it called again? I can't remember the name of the project. The database which we can query, not compute. Doesn't matter. I'll share the link later. But essentially, there's a big database where they drop every single page, like an index of every single page that HTTP Archive analyzes, and every request that that page that page makes. So if a page makes 30 requests, we have that database kind of stored. And you as a normal developer who might be interested in performance can go out and actually query that information. And what I'll do is I'll share a tweet out later around kind of the name of the service and kind of what you can do to do this. But I did some of this kind of basic aggregation before. Yesterday it was from last week's data set. And I looked at the CSS files, the HTML files, and the JavaScript files. And it's pretty clear that, like, you know, there's 39% of the web that don't bother compressing, or 39% of the requests that go out from a browser, that when they find the CSS file, they'll download the full file and it won't be compressed. There's no compression turned on for that. That's pretty huge. 40% of the web doesn't bother compressing CSS files. And HTML is worse, right? Normal pages, index pages that you go to and navigate around, they don't turn compression on for nearly half of the web. That's pretty crazy, especially when you're on a mobile device. Now, the interesting thing is actually JavaScript is 16%. So you're around about 84% of the web compresses JavaScript. And when you dive into this, it's because a lot of JavaScript solutions are based on CDNs. So like Google have got jQuery and a whole lot of other kind of frameworks hosted on a CDN, and those CDNs will make sure that content is compressed. HTML and CSS, normally if it's your own server, you probably haven't turned the compression on. And I think that's crazy, and in most cases, actually turning compression on, especially in Apache and Nginx, is a one-line configuration change, and it doesn't really impact the speed of your service at all from a processing standpoint. So we also do a lot of analysis on PageSpeed Insights to scripts and CSS. And what the specific piece of analysis that we do is a thing called render blocking JavaScript and CSS. It turns out the way that the browser gets JavaScript and CSS from the server has a dramatic impact on the performance of your application. And we try and tell you as a developer the things that stop the layout from happening, the things with regards to your CSS and JavaScript, which will cause your page not to be painted to the screen quickly. And this is Google Analytics. Like, even some of our services don't have a great kind of, we don't follow our own guidance, I suppose is what I'm trying to say in a lot of these cases. And we're going to talk about what render blocking means in a minute, or now in fact. I heard a quote, and I'm trying to find out who actually said it, but they said the fastest sites will have no scripts and CSS. Which is true, right? If you just send raw like HTML to a service or to a user, it's going to be really quick because there's no subsequent requests. But you're going to be pretty bored on the internet. There's no interactivity or anything available, and it's going to look pretty ugly. So you have to make JavaScript. You have to use JavaScript. You have to use CSS, and that's where the actual problems with performance and getting data down to the client so that they can use your website or application actually happen. So we have this thing called the critical rendering path. And basically, it's a combination of the DOM tree, which is your kind of HTML and your HTML structure, and the render tree. Now, it's a little bit hard to understand, and I know people at the back won't be able to see properly. But there's essentially two core components to the browser. There's the DOM structure, which is, if you look at this section here, which is your document, your HTML element, your head title, the body, the structure of the semantic HTML essentially that describes the page. And then there's this render tree, which is essentially a combination of this, well, it's not really, it's a combination of the DOM tree and the CSS object model. Now, the CSS object model is the thing that essentially presents the content from the DOM tree to the user. And the two have to be done and complete round about the same time, otherwise you don't actually get any content. The thing to note about this and why it's important and why this actually blocks the rendering is because imagine you've got a HTML document and there's an image right at the bottom of the page. And that's in the DOM structure. You know, it's the last thing that the browser gets. It's at the bottom of the DOM. If you have your CSS might actually say that image is hoisted to the very top of the page because it's got absolute positioning. Use position absolute, 0, 0, and it's pushed right to the top of the page. Now, if the browser didn't wait till the DOM was complete and the CSS object model was completed, then you would see the image pop in at the bottom of the page and then jump up to the top of the page. And that's not what any browser vendor actually wants to happen. So there's these two kind of competing kind of structures inside the browser, which you have to get exactly right. And we're going to talk about how you can ruin that experience completely. So this is the HTML5 parser, roughly as it's defined. I say roughly as it's defined because it's not exactly how browsers work. But essentially, the browser or the document parser will go through all the HTML and make this kind of nested structure inside its own DOM representation. And what it does is when it detects a script, it basically says, well, this script is important, it's critical to the application or site. I'm going to not bother parsing the rest of the document. I'm going to wait for the script to actually return and load and execute inside the browser. Now that actually stops this kind of subsequent, you'll notice that there's a link element there with a style. That stops that from being loaded. So basically, before you can get anything to the screen, that script has to be downloaded. It's not quite how it works. You know, a lot of browsers have a speculative parser which will go off and start to download other scripts as well. But fundamentally, if you have a script element, it has to stop doing what it's doing, process the script, and then get back to it. Which, when you think about trying to get data to the page to the user as quickly as possible, is pretty bad. Imagine you have to go off to get the jQuery library before you can actually see anything on the screen. And if that takes 200 milliseconds to get from somewhere, that's 200 milliseconds lost that the user won't actually see the page. So it's pretty interesting. So yes, scripts block the parser. Most scripts or old style scripts, this is the Google Plus one button. Most scripts where you have, for instance, social widgets, whether it's Twitter, Google Plus, those type of things, if you don't use them correctly, you can really slow down the performance of your page. And the reason why the script actually does a whole lot of stuff, the scripts block is one, because it has to execute, but at the same time, there's a potential chance that the browser or the developer might have included a document.write inside there as well. And if they include a document.write, it has to go off and reparse the DOM. So that's why, for instance, without the speculative parsing at least, excuse me, without the speculative parsing, you basically have to wait for the script to execute, which again obviously slows down the page. Now, the interesting thing is that the browsers have made a decision as well that if you actually download any JavaScript, you probably have to wait for the CSS to download as well. So you might have all how to say this, you've got the link elements and you're downloading your style sheets and they're getting downloaded, and you have maybe 3 or 4 different style sheets in place. Now, the JavaScript might have a get computed property or get computed style, which would return the position of the element inside the DOM tree. Now, when that actually, or the render tree, sorry, when that actually runs, you want it to be accurate. You don't want it to say, well, you know what, the CSS hasn't downloaded, so the image that is at the bottom of the page actually is still at the bottom of the page, when in actual fact the developer, when the CSS was applied, wanted the image to be at the top of the page. So browsers like Firefox, for instance, completely block. They basically completely block if there's any JavaScript actually being downloaded, because they want to ensure that any CSS style sheets that are being downloaded are actually downloaded and applied at the correct time, so it's as accurate as possible. And that is probably one of the reasons why having JavaScript inline is actually, well, JavaScript that requests a page at the top in your head element is actually a really bad thing. And actually it turns out that rendering is also blocked on CSS. They don't want this kind of flash of white, unstyled content happening to the user every time. So in many cases, they will not display anything on the page until all the link elements that it's found have actually been downloaded. So yeah, JavaScript can block the DOM construction. JavaScript can also be blocked from downloading and executing correctly on CSS, waiting to be downloaded. And rendering is always blocked on CSS in most cases. So if you don't have your CSS files downloaded in time, you won't see anything on the screen. So the interesting thing I want to kind of talk about is this idea of the perception of performance, which is a trend that's happening in web development at the moment. It's kind of it's a recognition of that we can't break the laws of physics. We can't get data and really data delivered any faster to us. We can't have the data break this, we can't basically break the speed of light, I think is the easiest way of saying things. So we have to fake a lot of things. We have to basically tell the user something is happening, even when it is happening, but they don't know it's happening. It's really weird, and I'll explain it properly, right? The British love to queue. I was in the airport, and I was greeted with this. There was some fog. The planes couldn't take off. So there was basically backlogs of traffic and queue for people. And I was in this queue for 3 hours, and I stayed in the queue for 3 hours because I wanted to get my next flight. And by the time I got to the front, all the flights had gone, and I couldn't get a flight to Berlin at the time. So I had to go back home. And it was It was really annoying. And I was just stood like everyone else for 3 hours waiting politely to get to this point of trying to be able to get a ticket. And I was really annoyed throughout the whole process. And it's because I knew I was there. I couldn't do anything. Nothing was happening. There was no one to speak to, kind of to help you out and help you get to where you're going. Like nothing was happening. My perception of the performance was like I was just stuck in a queue waiting for absolutely ages. Now, when you look at modern airports and the way they're starting to design airports, is they recognize that actually in airports there's lots of queues and people stand around waiting, doing absolutely nothing. So one of the things that they're starting to do is make you walk a lot further. Like you'll get off your plane and you'll go down a long alleyway and you'll keep walking and keep walking and keep walking, and then you'll go through some security and then go and collect your bags. And what it makes you think is like, well, you get to the end and your bags are waiting on the carousel, you pick them up and then you take them home. You're like, that was really quick service, that was brilliant. I got off the plane and my bags were waiting for me just as I got there. But actually, in fact, and I just realized you can't read this, in fact, your bags take the exact same amount of time to get from the aeroplane to the carousel. It's just that in that intermediate time, you've been doing something else other than standing around. So it turns out people complain a lot less when they have to walk further and do something. And that's what we want people to do with web development. If you're building sites and services, you can actually get something to the screen as quickly as possible, make the user think that the site is fully interactable and you can actually interact with it, but actually then kind of download like the rest of the content behind the scenes and bring it out as quickly as possible. So it's kind of an interesting kind of paradigm. And I want to kind of talk about it in two different ways. The first is the DNS problem. As sites get heavier and heavier and heavier, they use more and more external scripts. They refer to more and more external domains. They might have kind of social widgets, whether it's a Google Plus widget or a Twitter widget, for instance. And we saw earlier on that a DNS connection, it can take up to 200 milliseconds on 3G and 80 milliseconds on 4G. This is a really big problem, especially when you look at this. On average, there's 17 external references, or external sites per page now on the web, which is just crazy. There's 17 DNS lookups that you have to do every time you load a page. So the perception of performance, you can't really get around the fact that you want these social widgets and all these kind of interactive kind of components on your page, and someone else provides them. So you want to do a thing called DNS prefetch. Now, Firefox and Chrome implement this, but basically what happens is right at the very top of your document, you put a link element in with a href of the domain that you want to pre-resolve. And what basically happens is the browser goes, hey, we're going to get something from twitter.com. Let's go and resolve twitter.com to make sure that the DNS is not going to be the problem when it comes to downloading the script. And the example I use here is the BBC News site. I was in our Korea office yesterday, and I was looking at the BBC News site, and it took about 10 or 15 seconds to load. And I know the BBC is a really good site. In the UK, it's probably about 100 milliseconds to load the entire site. And I looked at the way that they've actually structured their page, and each of these scripts are normally on a different domain. They shard all the scripts across domains. And the DNS lookup was taking 139 milliseconds. They don't do any of the prefetching that you can do. And if they'd done the prefetching, then maybe the first request would still have to do the 130 milliseconds kind of DNS resolution. But all these other subsequent requests that are all on different domains, well, the browser would have gone off and gone, well, I'm going to get these ahead of time, and then they're all pre-resolved and ready in place. And it's a relatively simple thing that you can do to your page to kind of boost the perceived performance. You don't actually really change the real performance of the page, but the fact is the browser's going off to do something ahead of time that the user doesn't actually see kind of that work happening. And it's pretty interesting, it's pretty cool, and it's easy to implement. The next is above the fold, and I know Paul Irish talked about this earlier on as well. The above the fold content is everything you see in the very first screen's worth of content, right? What the browser actually sees, and I know it's very small, the browser sees the entire page, the entire DOM, all the images, all the CSS that's applicable for the entire page. And the question that you have to ask is, can we just download what's needed at the top of the page, and then a little bit later, once it's displayed, download the rest of the content? Well, not the content, but the CSS and the JavaScript that is applicable just to this bit. You don't change the amount of content that is being downloaded to the user. You're just changing the kind of the perceived speed and like the perception of speed. because you're saying, actually, this first piece of content here is the most critical, the most important, and we'll get that out to the user as quickly as possible. So when we want to talk about optimizing CSS, there's one quick win. And if I was working for the PageSpeed team, which I'm not, the only thing that they would ever suggest is to install either mod PageSpeed or Nginx PageSpeed, because it's going to do everything automatically that I'm going to show you now. The first, obviously, these are just bullet points, and I'm really sorry that they're bullet points, but they're just a list of things that every developer should do when they're actually building a site. You know, put your CSS early in the document, put it before a script so the scripts don't block. Actually, you probably should put your scripts at the end of the document itself. Make sure you minify, compress, and cache all your jobs or all your CSS files. That's the best thing that you can do for the users in that case. And then generally reduce the number of requests. We saw from the BBC before they're making, well, this is JavaScript. They also have about 4 or 5 different CSS files that they download as well. Just concatenate them into one file. And then inline in the head where possible. And the inline in the head element is what we're going to talk about next. Well, actually, it's not. I lied. I'm sorry. So the first one is use only the CSS that is needed for the page. If anyone's used Bootstrap, the kind of the CSS framework for making nice looking applications, it's 120 kilobytes in size, which is pretty big. But most applications don't use the entire range of functionality from Bootstrap. And some experimentation that we've done where we built an application, went through every single page in that application to look at the very specific CSS that we used. We managed to reduce that file down to 11 kilobytes. And you'll see this better like when I share the slides, but this is the code that we used. It's a small piece of JavaScript which walks through a DOM, and then for every DOM element works out what CSS rules are applicable, and then just saves them to a file, which is pretty cool, right? We've basically reduced the size to 10% of the size of the original file just by being smart about how we actually want to serve up that content. There's another simpler way. I don't know whether Paul Irish showed it before, but there's an audits panel in DevTools. Basically, that just lists all the CSS which is not used. If you find some CSS that's not used on the page, you can pretty much safely strip that out. And this is the one about inlining critical CSS. The critical CSS is the content that is the CSS that only applies to things in the above the fold, which is basically the content in the first screen's worth of your page on your mobile phone. Now, it's a little bit more complex, but the reason why this is important is because if you inline the content, you're not making a request at the time of trying to get the content to the screen to an external CSS file. You don't have to wait for that request to complete to bring it back in. Now, that's really cool because it stops blocking and helps you get the content visible on the user's device, but it's actually really hard to work out what is visible on like above the fold at any one time. And this is the technique that we're using at the moment. If you go to my blog, paul.kinlan.me, I explain it a little bit more there. But essentially, we walk the DOM again, and we look to see whether it's in the viewport at any particular time, if it's in the top part of the viewport. And that's all it is, but it's not 100% accurate at the moment, and we're trying to work on that. But it's a good heuristic that you can use. And this is like an example of what it looks like. I know Paul Irish talked about it a little bit earlier on, but this is the inlining of the content which is only applicable for the above the fold. So it's the above the fold stops here. Anything beneath this would not be on the first part, like the first screen's worth of content. So we've just analyzed the fact that the body element is important, the H1 element is important, and the div is important for us. We've worked out the CSS that is applicable, and then we just basically push that into the style element at the top. So no request to an external service is going out from the head, which means that we can display this content in just one request. So you have to ask the question, what about the rest of the CSS? Well, you basically subtract the two sets of property, or the two sets of CSS style rules, and you have a link rel style sheet at the bottom. You'll potentially get a flash of unstyled content if the user scrolls and they scroll past the link rel, which has not been downloaded. But generally, you can get content to the screen really, really quickly with this technique. This is pretty cool. Optimizing scripts is another one. We know that scripts block the rendering quite significantly. So what are the techniques that you can use to improve this? Well, again, if I was working for the mod PageSpeed team or the PageSpeed team, I would just tell everyone to install mod PageSpeed or Nginx PageSpeed. But I know that everyone either can't control their deployment environment and don't want to install kind of new server software. So we're going to show you how to actually do some of this stuff now. But again, it's exactly the same as CSS, optimizing for CSS. You need to deliver it to the user as quickly as possible. You need to compress it, you need to minify it, and you need to reduce the number of requests that go out from your page. And JavaScript normally is the one where there's normally a lot of extra DNS resolutions applied, because the JavaScript will be on different content distribution networks. So in this case, using DNS prefetch for your script is actually probably a pretty good thing. But make sure you remove all the scripts from the critical render path. Try and have no script above any area that will be displayed on the page in the very first screenful's worth of content. I know it's hard to do. You might want to do some interaction with the DOM at that time, but just try and defer as much as possible, because like it really does slow down the amount, slow down the speed of your page. So you can get around it to some extent. I might have actually got the syntax wrong, but you can use async. So there's an attribute at the end called async, which is available on the script elements. Now, async basically says, I'm going to download this script, and I'm not going to block the DOM parser from doing the rest of its work. But what this actually means at the same time is that you could have 3 or 4 different scripts with the async attribute applied, and it will download them and execute them in any order that they come back. So if script A comes before script B, then B will probably execute. No, script B comes. Sorry, I'll rephrase it. If script B comes before script A, then script B will execute before A. And if you have a dependency on 2 or 3 scripts, you don't want to use the async attribute, because you can't guarantee the order of execution. And you shouldn't really use it if you're going to manipulate the DOM. If you've got document.write or any kind of other thing in place there, it's really bad, because what might actually happen if you've got a very large document, like the HTML5 spec, for instance, it's multiple megabytes in size. You might have some JavaScript which downloads, and then it executes. The DOM element that you want to interact with at that time might not be available, might not be on the screen, just purely because actually the JavaScript was actually quite small in comparison to the actual HTML document. So to kind of get around the unordered execution of asynchronous scripts, there's a defer attribute. And defer does something similar to async. It basically says, you can go off and download this file, and I'll continue passing the DOM and let all the CSS apply and a whole load of other stuff. But it actually blocks the onload event. It basically waits for all the scripts to complete, executes them in the order that they were specified in your script to ensure consistency. Script A executes before script B, which executes before script C. And you can kind of ensure some consistency there. It's kind of useful for taking out that blocking. It's useful for taking out the blocking aspect of scripts. But again, you don't particularly want to rely on interacting with any DOM at that time. You want to wait till this page onload, and then kind of get the content back out. So you can defer, and that will actually speed up your page. One of the things that a lot of Google services tend to recommend is you literally just put all your scripts at the end of the page and wait for the scripts to execute then, rather than use async or defer. So what are some of the tools that you can use? Well, obviously DevTools is one of them. DevTools is really cool because you can connect it either to your desktop machine or directly to your network, to your mobile phone. And what this means is that if you're on your network, if you connect DevTools to your mobile phone, you actually see the network that all the rest of your users would see, essentially. All the requests that happen, the latencies that you see would be probably pretty similar across the rest of your users on mobile as well, which is pretty cool. But that gives you a good, strong indication about kind of what's blocking, when it's blocking, and how to go and fix these things as well. The next is PageSpeed Insights extension, which I'll see if I can demo briefly. There we go. Here's one here. Let me refresh. If this works. That didn't work, did it? News.bbc. Come on. See, the BBC takes a while to load. A lot of their servers are in London. No. Okay, so you can tell this is code I've written. It doesn't work. Let's go back to the presentation. So essentially what would happen is every page that you visit, the extension goes off and checks the page against PageSpeed Insights service, which will then give you this report. It'll basically tell the size of the HTML, the data in the HTML, the size, the total size of all the images on the page, and a whole lot of other features. But it also gives you a screenshot of what it looks like on a mobile device and the suggested fixes that you can do. So if you've got a site and you're testing your own site and you're navigating around it, this extension is pretty cool because everywhere you go, the extension checks basically the mobile performance of it. So it's pretty cool. And that's the link I've got in there. It's 9TTKS. It's pretty cool. The next is a mobile speed monitor as well. This is another service that we've written, which is a Chrome app, which is what Pete LePage talked about earlier today. You can basically put in a whole series of URLs, and every 10 minutes, you will go off and run some analysis on it. So you can basically see and check for a whole range of pages inside your site, whether they're performing well and whether they're consistently performing well as well. So it gives you some warning ahead of time that something might have gone wrong if you've just deployed some software onto the web. So in summary, delivering performance, it should be a feature. It's not for a lot of developers at the moment. So it's something that you go and fix at the end of your development project. We want you to kind of go and think about how you build your applications ahead of time. So use PageSpeed Insights to get actionable advice. You know, PageSpeed Insights will tell you all the things that it thinks are wrong with your page and how to go and fix it. But always ensure that you do the basics, right? Try not to use redirects if possible at all. I know you can't get away from it sometimes, but just follow that piece of guidance first. Try and never redirect the user to another domain or another page. Always concatenate, minify, and compress your scripts. We didn't talk about it today, but optimize your images. Images can be optimized far more than what we think they can be. You can change the compression settings on your JPEG files, and you will save a lot in bandwidth for the user. Obviously, compress everything and cache heavily as well. And one of the areas is at the start of your project, plan for inlining critical CSS. I don't think anyone in this audience is going to go off tonight and inline critical CSS on their web pages. For an established project, it's just not feasible. But if you're starting to kind of build your project now, you can start to think about how you can get those inline styles into the head element and then kind of break that up so that the rest of the CSS is loaded later on and you're getting the users or the content for the user on the screen as quickly as possible. And we say deliver above the fold content in the first 15 kilobytes. There's a very specific reason. If you set up your server correctly, you can send 10 TCP packets out with 15 kilobytes worth of content before even having to send a response back. That is actually a really hard one to even solve, and we don't even do it ourselves at the moment. So just try and get as much of the content out to the user as quickly as possible and get it on the screen within a second is our overall guidance. And that's the end. I finished. That's it. I've got one final thing. If you have any feedback on any of these features, I know we haven't got time for questions. Paul Kinlan at google.com, or I'm on Twitter and GitHub and everywhere else. Just send me the feedback. Don't worry about whether you can or can't. Just send me the data and send me the information that you have. It'd be really cool.